This is Chapter 3 of Collingwood's Precalculus textbook. This is the University of Washington's Math 120 textbook. In Chapter 2, we looked at a coordinate system, which we labeled with axes of x and y. And on this coordinate system, we considered points. We modeled these points using ordered pairs. And we even considered some moving points. We considered analyzing motion on a coordinate system, and we used an ordered pair with a variable in order to represent a moving particle or a moving person. In particular, we saw something like this to describe someone's position at time t. At time 0, they're at 0, 0. At time 1, they're at 15, 0. In Chapter 3, we shift our perspective. Instead of looking at points, we look at curves. What exactly do we mean by a curve? A curve does not necessarily mean something curvy. A curve could be completely straight. A curve could have right angles. What we mean by a curve, loosely speaking, is something that you could draw with a single stroke of a pencil. So for example, we might look at this curve. Here is a perfectly fine curve on a coordinate system. Now, in Chapter 3, we're going to look at 3 simple curves. These curves are horizontal lines, vertical lines, and circles. What are we going to do with these curves? We're going to see with each of these curves 3 different ways to look at these curves, 3 different representations of these curves. What are these 3 representations? Our first representation of curves is the one we've seen, this one, a visual representation. We see that this curve is, well, it's this one. It's the one that looks like this. There's only this one that looks like this. All the other curves look a little bit different. With a curve like this, I'm not really going to be able to give you a representation of it other than this visual one. Unfortunately, I can't really boil it down to some simple mathematical statement. But with simple curves, like the ones we consider in this chapter, we'll be able to view them not just in this visual representation, but also in a couple of other forms. So let's take a look at a simpler curve. We'll start with a horizontal line. Let's work with a specific one. I'd like to say verbally what specific line I mean, but at this point in our vocabulary, I don't have a way to speak a horizontal line. I don't have a way to communicate orally a horizontal line. And for that matter, I don't really have a way to communicate in writing a horizontal line either. But I can certainly draw one to specify. So I've drawn my line, including all the bits and pieces, the little details. I have a coordinate system, and I have this line that, well, it's kind of like this. We have a word for that called horizontal. How can I really describe this line? Well, using the vocabulary we developed in Chapter 2, I could certainly specify some points on this line. I've written 3 points on this line. And using these 3 points on this line, I'm going to give 2 more representations of this horizontal line here. So one of them should be familiar from your experience in algebra. Looking at all of these points individually, I notice that there's a particular equation that I can write down that will be true for these points, and for these points, and for these points. In particular, I'll write down an equation in terms of x and y that when I plug in this number and this number, I will get a true equation. Here, it's particularly easy to write it down. And we have our second representation of this line. Our first representation was visual, and our second representation was in the form of an equation in terms of x and y. Our final representation of this line is a little bit newer in a pre-calculus course. In higher mathematics, we start seeing these symbols all the time. These curly brackets denote a set. What do we mean by a set? We mean a collection of objects. So in this final representation, we specify the line by saying, well, it's the set of this point and 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 this one and this one and this one and this one. And every single point that's on this line, we write down some representation of all of those points, of that entire collection of points. And we say, well, this line is that collection of points. So how do we do this? What sort of notation do we use in order to describe an infinite collection of points? Well, here's what we do. Ideally, this entire phrase would have fit inside this, but I hope you'll forgive me. So what do we mean by this, and how do we even read it? We say the set of points x2 such that x is a real number, or where x is a real number. What do we mean by this? Well, we mean if you specify a real number, say let x be 4, then 4, 2 is part of this collection. And for any possible specification of x, as long as you specify a real number, the point that you would get by plugging in x into this ordered pair is part of this collection. So we take the collection of all of these points, and this is our representation of the line. So we've seen for this horizontal line our three representations of curves. We have our visual representation in the form of a graph. We have our equation representation in terms of x and y and some equal sign written here, although no x's happened to appear here. And we have our set notation, which we've described here